In this example, and in the following example, I'm going to show you how to find exact trig function values for different angle measures. In this case, I'm going to look at the cosine of a 5 pi over 6 radian angle. The first thing that you might want to do, especially if you're working with radians for the first time, is to make a conversion before you do anything else. So I know that pi radians is equal to 180 degrees. So I'm really taking 5/6 of 180 degrees, 5/6 times 180 degrees. I know that 1/6 of 180 degrees is 30 degrees. 5 times 30 is 150 degrees. And that's what my angle measure is going to be. Now the second thing I need to do here is I need to graph this in standard position. So if you remember, the vertex gets graphed at the origin. You draw your angle back this way. First quadrant, your angle is going to move through 90 degrees. Remember that a counterclockwise motion is considered to be positive. And it's going to go over here. And so we get something that looks kind of like this. So this is the initial side. This is the terminal side of the angle. And basically I have a 150 degree measure over here. And the next step is actually very important. Normally when you think about trig definitions, you think in terms of right triangles. For example, we know that the cosine of an angle is equal to the adjacent side over the hypotenuse. Well, in this case, you look at this diagram and you don't see a right triangle. So where does the right triangle relationship come from? Well, the answer is very simple. You always create a right triangle by dropping a vertical line down to the x-axis. It has to be perpendicular to the x-axis. You don't want to draw it going over in this direction. You want to draw it down to the x. And now you can say I have a right triangle here. If this angle is 150 degrees, this angle over here is 30 degrees. Not drawn very much to scale, but you've got the measurements there. If you're going to be doing one of these by hand, that angle is probably going to be either 30 degrees, 45 degrees, or 60 degrees. Now, terminology. This is what's referred to as the reference angle. Any calculation I make after this is going to be made using the reference angle. And what I'm going to do is I'm going to label this triangle using any possible labeling that will work for a 30, 60, 90 triangle. Probably the easiest is to make the short side 1. Remember, the short side will be opposite to 30, especially if your diagram's not drawn very much to scale. You need to be real careful with that. Double it to get the hypotenuse. The adjacent side here would normally be radical 3, but notice I'm going backwards in a negative direction, okay? So I'm going to write that as negative radical 3, okay? This goes upwards, so it's positive. The hypotenuse value will always be positive, and that's something you need to be careful. So hypotenuse always positive. The horizontal and vertical distance could be positive or negative depending on how they're graphed, and that's what's going to change from what you've done with right triangles prior to putting them on a coordinate plane. Okay, so now, very easy. The cosine is just the adjacent side over the hypotenuse. So you go to your reference angle. You never use that 150 again. The adjacent side is negative radical 3. The hypotenuse is 2. You're done. Okay, if you check on your calculator, that's the same value as the decimal that pops up on your graphing calculator. If I wanted to find the secant is the reciprocal. It would be negative 2 over radical 3, although you might want to rationalize your denominator as well. If I wanted to find the sine of 5 pi over 6 would just be the opposite side over the hypotenuse. That's going to be positive 1 over 2. So it doesn't have to be negative. Some of the values are going to be positive. Some of the values are going to be negative. The cosecant is the reciprocal. And so the cosecant is just going to be 2 over 1 or 2. So you can find lots of other values very quickly. In fact, you can find all 6 trig values extremely easily once you've got your triangle drawn in standard position. So that's the idea. It's all about the reference angle. Okay. By the way, a little reminder that you may see in some places. Many teachers use the little abbreviation, all students take calculus, or some variation on that, to help students remember which functions are positive in which quadrant. Okay? All 6 trig functions are going to be positive in the first quadrant. Sine and its reciprocal, cosecant, are going to be positive in the second quadrant. In the third quadrant, tangent and its reciprocal, cotangent, will be positive. and then cosine and its reciprocal secant will be positive in the fourth quadrant. So again, you should be able to see this by putting in your signs when you label your triangle, but if you forget that or you want to go back and check at the end, it's a really nice way to do that. And also if you've memorized some basic trig values, like if you know the sine of 30 degrees is equal to 1/2, sometimes you can get to a point where you can skip the process of trying to draw this, although certainly when you're learning you don't want to skip that. Let me do one more example here. In this example, let me find the secant of 7 pi over 4. Okay, same kind of thing as before. You graph your angle in standard position. 7 pi over 4, that's going to be 7/4 times 180 degrees. A fourth of 180 degrees is 45 degrees. Notice this is 1/4 short of 2 pi, which would be 360 degrees. So that's going to be 45 degrees less than 360, which is going to end up being 315 degrees. So I'm going to graph that. Once again, I have my angle in standard position, vertex of the origin. Here's my initial side. It's positive, so I go counterclockwise. 90, 180, 270. The 315 actually comes all the way over to here. It's actually this whole thing like that. There's your 315 degrees. Okay, the reference angle always formed by dropping a perpendicular back to the x-axis. Okay, so actually my reference angle is going to be this angle right here. It's a 45-degree angle. Again, you can pick any side lengths you want. In my case, I'm going to pick side lengths of 1, 1. Be careful. This is going in the positive direction. This is going down, so I usually label that a -1 so I can keep my sign straight, and this is going to be a radical 2 on that side. Secant is the reciprocal of the cosine function. Cosine is adjacent over hypotenuse, so this is going to be the hypotenuse over the adjacent. Hypotenuse is radical 2, the adjacent side here is +1, and so we just find out that the secant is equal to radical 2. The cosine would be the reciprocal, 1 over radical 2. You could rationalize the denominator there. If you wanted to find the sine of that angle, of a 315-degree angle, that would be opposite over the hypotenuse. That'd be -1 over radical 2, which rationalizes to negative radical 2 over 2. You could do tangent. Tangent would be opposite over adjacent, -1. Of course, the reciprocal of that would also be the cotangent. So you can find lots of different trig function values very quickly if you draw your triangle in standard position, or specifically if you draw the angle in standard position, find your reference angle coming off from that. So again, relatively straightforward, relatively easy. Now, last example here. You can also be given something in reverse. For example, I could be asked to find all 6 trig values for a second quadrant angle. Second quadrant angle that has a cosine of -3/5. Okay, so now we're going backwards. I want to find the actual, well, don't necessarily want to find the angle measure, but I want to find the 6 different trig functions. So I already have cosine of that angle. Basically, I want to find the secant, the sine, the cosecant, the tangent, and the cotangent. Again, if I get a picture drawn, this is going to be pretty easy. So one way of looking at this is that this gives me, cosine gives me an adjacent side over a hypotenuse. So I should be able to use that to draw my angle. And again, that's going to look something kind of like this. The adjacent side, this is actually being drawn in the standard position, so basically the original angle would be going something kind of like this. Keep in mind if they ask you for the measure of the angle, this is actually theta, but I'm going to end up using my reference angle here to create my triangle. So here's my triangle. We're told, again, I'm using this angle right here. We're told that the adjacent side of that is -3. Notice it's going back 3. That puts it in this quadrant. I have to be told what quadrant it's in because the hypotenuse length is always going to be positive. And so I could also have an angle that comes down here that has the same cosine because it would also have that negative horizontal value and it would have that positive hypotenuse length. So you do have to be told a quadrant. So this is -3, this is 5. And if you notice, this is a little 3, 4, 5 right triangle. that's upwards, so it's positive. Okay, if I was given an angle in the third quadrant, we would have a negative 4 coming down here. And basically we can fill this out. We know that sine of an angle is equal to the opposite side over the hypotenuse. That would be 4/5. We know that the cosecant is the reciprocal, so that'd be 5/4. I already have the cosine. We know that the secant of that angle would just be the reciprocal, negative 5/3. We know the tangent of the angle is going to be the opposite side over the adjacent side, which is negative 4/3. And we know that the cotangent of that angle is going to be the reciprocal, negative 3/4. So again, if you draw a good picture, pretty straightforward, not very hard to put this whole thing together and find those missing values.